The James Webb Telescope has essentially provided the most precise image of Proxima B in history, revealing breathtaking snippets of knowledge into a possibly tenable exoplanet. It supports us as we embark on an excursion through space to uncover the secrets of Proxima B and find out if it might be the next Earth. We ought to take off into the vast expanse of space, where a mysterious planet exists in the star's habitable zone. This planet is much more than just any ordinary rock, it's real. Proxima B is discovered just 4.2 light-years away from us. There are many mysteries on this planet and wonders. Could it be another Earth with seas and life blossoming on its surface? However, there are additional Proximas in that system. Centauri B isn't the only one. Around the red dwarf star, it has a companion, Proxima Centauri C, and who knows what other mysteries the star system holds. Maybe there's another companion that we haven't yet discovered. The secret doesn't stop there. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface, and perhaps even life? As we explore beyond our own solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, there are countless opportunities for exoplanets. Some exoplanets even wander freely, untethered to any star, like wandering space travelers. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. With a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun, indeed, one side of the planet is constantly washed in sunlight while the opposite side remains in everlasting darkness. Now, let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigel Kentaurus, who goes by the name Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our solar system. Stars Alpha Centauri A and B form a binary system known as Alpha Centauri. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star, an M-type star, about 21 light-years wide from the other two stars, typically about 4 times as far apart as Earth and the Sun. It is the closest star to us. Proxima in fact means the closest in Latin. It was found in 1915 by Scottish astronomer Robert Thorburn. Despite being the closest stellar neighbor, it is not visible to the naked eye, with an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal processes of convection at their cores keep them shining for, generally speaking, trillions of years. Proxima Centauri will continue to be a main sequence star for an additional 4 trillion years. On the other hand, the habitability of a red dwarf star like Proxima Centauri is still debatable. One argument is that it is a flare star, meaning it has frequent and intense explosions. As a star with a low mass, its habitable zone would be much closer to it than the Sun's habitable zone, projected to be somewhere in the range of 0.23 to 54 cents. But it's not as comfortable to live in as it seems. Proxima B is bombarded by intense ultraviolet light emitted by its star, frequently more powerful than the radiation we get from our Sun, so extreme that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can sustain life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and keeping a surface that is water-friendly. Without it, living creatures would be vulnerable to harsh space weather conditions, making life almost impossible. So, Proxima B might look like Earth from space, but from the surface, it is far from being able to support life. Scientists remain somewhat cautious, as there are numerous factors that make it inhospitable. The mission to reveal Proxima B remains a mystery, but one tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope finally launched in 2018 and is going to assist us in determining whether Proxima B is habitable. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate representations. Abby Tabor, a theoretical physicist at Harvard, demonstrates whether a planet like Proxima B can, besides being able to absorb light from its star, emit it as infrared light. The James Webb Telescope was made with the purpose of detecting infrared light. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or a planet with an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an environment doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is significantly denser than Earth's, and extreme temperatures that would make it impossible for life to exist. The journey to decipher Proxima B's mysteries is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space scientists are feeling the pressure to find ways to observe planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It is the exoplanet closest to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar as technology for future missions advances. It's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system, and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. In addition to these types, we have the rocky exoplanets, the most exciting category for those of us searching for life beyond Earth. These are worlds composed primarily of rock and metal, much like Earth, Venus, and Mars. Proxima B falls into this category, sparking intense interest among scientists. But there's more. Some exoplanets orbit 2 stars instead of 1, creating a spectacular double sunset much like the fictional world of Tatooine from Star Wars. These circumbinary planets challenge our understanding of planet formation and stability, showing that planetary systems can be even more diverse and strange than we ever imagined. Still, for all the wondrous planets we've detected, there are likely billions more awaiting discovery, some hidden behind clouds of gas, some orbiting distant, dim stars, and some roaming the galaxy alone without a star to anchor them. These rogue planets are free-floating, solitary wanderers, and their existence suggests that planetary formation and evolution is an even wilder process than previously thought. Advances in technology, particularly in the realm of telescopes like James Webb, allow us to peer farther and deeper into the cosmos, identifying planets that were once invisible to us. Instruments capable of detecting the faintest traces of atmospheric gases, like oxygen, methane, and water vapor, could one day reveal biosignatures, the chemical signs of life. But we must tread carefully. As history has shown, jumping to conclusions can be dangerous. A strange chemical signature doesn't necessarily equate to life. Non-biological processes, such as volcanic activity or photochemical reactions, can produce similar signatures. Thus, confirming extraterrestrial life will require a careful, methodical approach, one that involves multiple lines of evidence and, ideally, direct imaging. Even then, challenges remain. Space is vast. Light from distant planets takes years, sometimes centuries, to reach us. And despite our growing abilities, we're still restricted by the limitations of physics, by the speed of light, by the durability of our instruments, and by the sheer distances involved. Yet hope persists. Projects like Breakthrough Starshot propose sending tiny, lightweight spacecraft propelled by powerful lasers to nearby stars like Alpha Centauri. These probes, traveling at a significant fraction of the speed of light, could reach Proxima Centauri in just a few decades. Upon arrival, they could send back precious images and data, giving humanity its first direct glimpse of an alien world. Imagine receiving the first photographs of Proxima B's surface, of alien oceans glistening under a dim red sun, or mountain ranges that have never been seen by human eyes. Imagine the possibilities. If Proxima B, or any other exoplanet, is found to host even the simplest microbial life, it would revolutionize our understanding of biology, evolution, and our place in the universe. It would prove that life is not a cosmic fluke, but perhaps a common outcome wherever the conditions are right. On the other hand, if we find that Proxima B is barren and lifeless, despite being in the habitable zone, it would also teach us a profound lesson, that life may be far rarer and more precious than we imagine. It would make Earth's own biosphere, the forests, oceans, and living creatures, all the more extraordinary and worth protecting. In either case, the search itself is a triumph. It shows that we, as a species, are willing to look beyond our small, fragile world, to wonder, to dream, to explore. It shows that curiosity, not fear, drives us forward. The journey to Proxima B has only just begun. In the years to come, as technology improves and our reach into the cosmos extends, new discoveries will surely reshape what we know. Perhaps one day, not only robotic probes, but human beings themselves will walk upon alien soil, standing under the light of another star. Until then, we watch, we listen, and we dream, looking up into the night sky, knowing that just 4.2 light-years away, another world is waiting for us to study from afar. And please do not forget the Earth-like exoplanets, which are similar to our own Earth. These planets are available in sizes ranging from 2 times smaller than our planet. There are even super-Earths, which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets, Proxima Centauri b, was recently discovered. This planet, which revolves around the same named star, is considered a super-Earth with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b isn't alone, it has a companion, Proxima Centauri SE, which is much further away from the star. It has a period of about 5 Earth years in its orbit, and in 2020, it was discovered using pre-recovery Hubble data. What's even more interesting about Proxima Centauri is that it seems to be an extremely bright world, possibly due to the presence of a ring system. There's more to discover within the system of Proxima Centauri. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be known as Proxima Centauri d and is roughly the size of Mercury or Mars. Imagine living in an area where the night sky is filled with stars, as well as countless other planets, each with its own unique characteristics and orbits. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time to be a space scientist. While we don't yet have an accurate count of exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets are not without their difficulties. They are frequently hidden by the glare of their host stars, making them difficult to study. Still, with advancements in technology, direct imaging of exoplanets is now possible. For a direct image of an exoplanet, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be seen directly, but they provide a fascinating glimpse into the attributes and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. The gravitational pull of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures a star's light going out when an exoplanet passes in front of it. This method has given us useful information about the size of exoplanets, including distance and temperature. Here are a few amusing facts. Did you know that more than 22% of stars like the Sun have planets the size of Earth in their habitable zones, or the place where TRAPPIST-1 is located? 7 rocky exoplanets with water on their surfaces. Exoplanets like those in our solar system can also have natural satellites known as examoons. With more than 4,000 discovered exoplanets, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets have yet to be discovered. NASA's James Webb Space Telescope is revealing the universe's secrets, one discovery at a time. This extraordinary telescope has been gathering information and taking stunning images of the universe, revealing wonders previously unknown. It made a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a Sun-like star 700 light-years away, and this finding marks a significant step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we've never seen before, sparking excitement among astronomers and scientists throughout the world. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering data about the universe in the infrared. The light from the young emitting object known as 1104 illuminates the cool, wispy cloud behind the orange spots. The material cloud reveals light from distant stars obscured by the ice in the cloud. This remarkable research was part of Webb's Ice Age project, which aims to study the formation of ice, from its creation to the formation of frozen comets. And that's not all. The James Webb Space Telescope also envisioned the workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared. Proxima B is an intriguing exoplanet that has captured the attention of astronomers and scientists alike. The discovery of this Earth-like planet, just 4.2 light-years away and orbiting within the habitable zone of Proxima Centauri, has opened up possibilities for future exploration and research. As we go on to examine planets like Proxima B, the capabilities of advanced telescopes like the James Webb Space Telescope, JWST, are becoming more and more important to unlock the mysteries of distant worlds. The JWST's ability to detect infrared light allows it to gather information about the atmospheres and surface conditions of exoplanets like Proxima B, potentially offering insight into whether these planets might be home to life, oceans, and other vital ecosystems supporting conditions. The ongoing research and discoveries made possible by advanced telescopes like the JWST are opening new doors to our understanding of exoplanets and their potential for harboring life. As we continue to explore these distant worlds, we gain valuable insights into the conditions necessary for life to thrive beyond Earth. The study of exoplanets has also sparked a deeper interest in the possibility of extraterrestrial life, which has fascinated scientists, philosophers, and the general public for centuries. Each new discovery helps to shape our understanding of the universe and our place within it. As we study the atmospheres, surface conditions, and even potential moons of exoplanets, we are beginning to realize that the universe is much more complex and full of potential than we once imagined. In the search for habitable planets, the discovery of even a single world with the right conditions to support life would be a groundbreaking achievement that would have profound implications for humanity's future. Moreover, the presence of exoplanets with water or potential biosignatures further fuels the curiosity of space scientists. Water, as we know, is essential for life as we understand it, and its presence on other planets raises the possibility that life might not be unique to Earth. This discovery may not only lead to scientific revelations but could also inspire future generations of explorers to venture further into space, seeking to answer one of the most profound questions humanity has ever asked: are we alone in the universe? Looking ahead, space agencies around the world are preparing for even more ambitious missions to study exoplanets and their atmospheres. The upcoming launch of more powerful telescopes and spacecraft promises to bring us closer to discovering more Earth-like worlds, possibly even those that could sustain life. With each discovery, we are closer to understanding the vastness of our universe and the potential for life to exist beyond our planet. As technology continues to advance, so too does our ability to study these distant worlds. Whether through direct imaging, the study of light from distant stars, or detecting the atmospheric composition of exoplanets, our exploration of these distant planets will continue to expand. The mysteries of the universe remain vast, but with each new discovery, we are piecing together the puzzle of our existence and our place in the cosmos. The future of space exploration holds endless possibilities, and the next chapter of humanity's journey into the stars is only just beginning.